So what you have there is, in both the discharging and the charging, your current goes down. Let me grab another marker. So you start off with the bulb is burning brightly, and then the current declines exponentially. Like this. So that the bulb gets dimmer, and then dimmer, and dimmer. In theory, the bulb never actually becomes completely out, right? It's constantly approaching zero, but never quite gets there, because it drops by half, and in the next, in the first, say, 10 seconds, and then half in the next 10 seconds, and half in the next 10 seconds. But that rate at which it drops off, that's your time constant. So when I had, your time constant depends on your resistance and your capacitance. So when I had less resistance, I had the two bulbs in parallel, that's less resistance. The capacitor charged up faster and discharged faster. So that would be more like that. When I had the two, it was quicker. When I had the single bulb, then it took longer to charge and longer to discharge. If I had two capacitors in series, it got even quicker. So then it was like that. And then when I had the two capacitors in parallel, charging through the one, like discharging through the one bulb, then it was slower. Went like that. The general pattern is always the same. That's this, what they call exponential. An exponential decay. Now, in the capacitor, what's going on inside the capacitor, whereas the current always does the same thing. The current always starts off at a maximum, so the bulbs are always brightest at first, and then it dims. Then they dim down. The voltage in the capacitor, depending on if you're charging or discharging, will behave in just like this or just like this, flipped. So if it's discharging, voltage does the same thing. It goes down like this. But if you're charging the capacitor, then the voltage goes up in a mirror of the exponential. So I hope you've seen the capacitors and stuff helps you understand how this stuff works. In an AC circuit, capacitors will never have a chance, as the current's going back and forth and back and forth and back and forth. Capacitors never have the chance to fully charge or discharge. So in an AC circuit, a capacitor never gets to the point where it can block the flow of current. So in an AC circuit, capacitors will allow current to go through them in an AC circuit. Because remember that in an AC circuit, there's actually never any through that is happening in the first place. Everything's always just back and forth, back and forth, back and forth. So there's no actual movement of charge in an AC circuit. So, I wish that we could have this and ask questions and pass it around and, play with them in class, but we can't. So I hope this is somewhat helpful to sort of see them in action.